Okay. So let's say X-ray production. This is the X-ray tube. The shape is not that much. Okay. So let's see how X-rays are being produced. So what we are going to do here is, now I told you this is other way around. Okay. So electrons going to hit the metal targets and X-ray photon is going to be produced. The thing is, first of all, I'm covering this. Inside this only X-ray is going to produce, X-rays, gamma rays, a little bit harmful. So you can't, you have to protect and produce it. So what happens is, this we call as filament. So what we are going to do is, this photoelectric effect thing is going to come here. Now, this is a battery like that. Okay. So this battery means it has a voltage, right? 2 or 6 voltage, 7 voltage, 8 voltage, like that it has. So what I'm going to do is, I'm going to increase the voltage. Okay. Then what happens is, now this is a circuit like that, electricity, circuit. So what happens is, now current is going to flow. If current, normally electricity, we talk like current is flowing in this direction. Normally there is not a concept like current. Normally electrons only flow. We tell that opposite to the direction of electron flow, current is flowing. Okay. So now if the electron will flow in this direction, electrons are being moved. Okay. Now what is happening is, now electrons are being moved from this end. If I increase the voltage, the current will get increased. Then what happens is, this filament will get heated. Okay. So one of the property of electrons is, if we get heat and heat, the electron, what it try to do is, it try to get removed from this. Okay. That means normally chemistry also. Now the subject, there are electrons and this. If we give energy like that, electrons, it will be get promoted to excited state like that. Like that, what happens is, when we increase the voltage, it will get, due to the heating effect, the electrons, like, it will remove from this position like that. Then what happens is, now we have to produce photons, right? So what is our target is, this electron should go and hit the metal, then only photon will be released. Okay. So what is the concept is, first of all, I'll tell you.
I can't hear you.
Hello? Yes? How much?
Can you explain me again, miss? I can't hear you.
You can't hear me, wait. Sound issue. Hello, can you hear me?
Yes, miss.
Okay. So what is that? Okay. So from the beginning, now this we call as filament. Okay. So what is in the X-ray tube is, now what is my target is, I am going to heat electrons to this metal target. This we call as metal target. Okay. So what my target is, electron should come and hit this. Now what we earlier studied in photoelectric effect, any metal surface there are, but it is made up of lot of atoms. Similarly, this metal surface also there will be a lot of atoms, no? Yes. Then my target is, now here there are electrons. Now this is the nucleus, means electrons are revolving around this. Okay. So what happens means, now I am going to excite an electron, and that electron is going to come and hit this metal top. Okay. So what happens means, electron will come and hit this one, and it will get promoted to an excited state. Due to those energy difference, a photon is going to get emitted. So that is we call as X-ray photon. So how to produce that X-ray photon? In order to produce that X-ray photon, my first target is what? My first target is electron should go and hit this metal target. That means electron should move from here to here. So that is not easy. So I should make some way. So what I am going to do is, have you done electric field? Hello?
Yes, miss.
So now let's say electric field is acting in this direction. For example, from plus to minus, it is acting. So if I give a plus Q charge in an electric field, electric force will act in the direction of electric field. If I give a minus Q charge, the force will act opposite to the direction of electric field. Can you remember that theory? Electric field?
Yes,
F is
miss.
equal to Q? Yeah. Okay. Now, my target is what is I should accelerate the electrons from here to here. Then only it can go and hit this metal target. No. So the thing is now this electron is minus Q charge. Okay, electron is minus Q charge. That means if I want to accelerate the electrons here, a force should act in that direction. Then only it can move. Due to if I hit the filament, electrons will get removed. So for electrons to move from there to there, force should act. Then only it can get a small acceleration and it can go and hit. So to create a force here, in order to move that, there should be electric field. So what I'm going to do is I'm going to give an external potential like that. Okay, external potential I'm going to give. Then what happens is how to connect this battery is the important. If I connect this battery in this way, electric field will act in this way. That means electric force for a minus Q charge, it will act in the opposite direction. Therefore, this battery is wrong. Therefore, if electric force should act in this direction, then electric field should act in this direction. Always electric field lines originate from positive charge and terminate at negative. Therefore, the battery should be connected like this according to my diagram. Then there will be electric field. This is plus and this is minus. So this direction there will be an electric field. This minus Q charge. So electric force will act for a minus Q charge in the direction opposite to the electric field. Therefore, the electrons will accelerate and go and hit the metal target. Okay, this we call as the cathode. Okay, and this we call as the anode. Okay, you can tell if you ask to name this one, you can tell anode or metal target, and this one we can say cathode or filament. Okay, so you must be really careful when connecting this according to your diagram. So this battery, sometimes they may ask to draw and show this battery. So the first thing you should think is according to, sometimes they will give the filament this side and the anode this side. So the first main thing you have to think is now what is my target? Electron should go and hit this metal target. That means what? That means electron should move in this direction. There should be electric force in the given direction, right? So for electric force to act in the given direction, electric field, how it should be? We know from the electric field lines, it originated at the positive and terminated at the negative. If there's a plus Q charge, force will act in the direction of electric field. If there's a minus Q charge, force will act opposite. Now this is electron now. Therefore, force is acting in this direction, electric field should act in the opposite direction. Therefore, this should be plus and this should be minus. Therefore, this battery, this is how we can connect. So one thing we can do is if we can increase this voltage. If I increase this voltage, this will move even faster and hit the metal down. So what happens is now electrons are being removed and it is coming and going and hitting the metal down. Another thing in the X-ray tube really important is this should be vacuum or evacuated tube. So what is the reason we are using an evacuated tube is now if there are gas molecules, now gas molecules or something, electrons are moving now, electrons are moving towards the metal target. So if the tube is not evacuated, what happens means there can be gas molecules, okay, when it is going. Then electrons, what happens is, now if there's a gas molecule here, now electron is going. It can collide with the gas molecule and it can ionize. That means now what is our target is we should produce X-rays. X-rays high frequency. Near to gamma in the electromagnetic spectrum. Therefore, what is going to happen is electron only going to hit and produce the X-rays. Okay, therefore, if there are gas molecules in the going pathway, it can hit with the gas molecules and it can lose its energy. So we can't produce X-rays efficiently, right? Therefore, in order to produce X-rays, what we do is this tube we will evacuate. So you can tell the reason. Sometimes they can ask why we are using an evacuated tube to, in order to avoid ionization or to avoid scattering. Okay, otherwise you can explain. If it collides, it may lose its energy. Then we can't produce X-rays efficiently. Okay. So now draw this diagram. I'll give the reasons. What are the questions they can ask? Can you draw this diagram quickly? Hello?
Okay, miss.
Label it down. Sometimes they will ask put letter A and what is this? It's anode O metal target. This we call as cathode. This one, cathode of filament. Then what is this? This we call as the power supply. Power supply for the filament. Power supply for the. This is high voltage power supply. High voltage power supply. This is evacuated. Those are the parts.
Miss done.
Okay. Then write down this. X-rays are produced when accelerated electrons strike the anode. X-rays are produced when accelerated electrons strike the anode. Next
Okay.
one write down. So sometimes they can ask what is the purpose of using this high voltage power supply. Then write down purpose of using the high voltage power supply is to accelerate electrons from cathode to anode. This one, why we are using this reason. Purpose of using high voltage power supply to accelerate electrons from cathode to anode.
So if that is not there, we can't, the electrons won't go to anode.
Yeah, the thing is, if here electrons can come out from thermionic emission. In order to move, we have to create an external electric field. So to create an external electric field, we should give this battery.
Okay.
Can you understand?
Yeah.
Due to the electric field only, it is getting a force, right? That's why it is moving. Otherwise, not enough. Using heating, if using a small heating, we can't send electrons from this to this. No. Therefore, what we are doing is externally we are creating an electric field. Okay, this was a high voltage. It should be really powerful, not accelerate. That's why we call high voltage power supply. 10 to the power 4, 10 to the power 5 voltage, like that. So then what we are doing is creating an external electric field and electric force. It will get a small acceleration and will go and hit the metal target. Then next one, write down reason for using an evacuated tube. Reason for using an evacuated tube. So write down the reason is electrons can travel from the cathode to the anode without colliding with air molecules. Electrons can travel from the cathode to the anode without colliding with air molecules. That is one answer you can write. What I am telling, reason for using an evacuator tube. One answer is electrons can travel from the cathode to the anode without colliding with the air molecules. Or as alternative answer you can write, or to increase the efficiency of X-ray production. One answer, electrons can travel from the cathode to the anode without colliding with air molecules. Or else you can say to increase the efficiency of X-ray production.
So when it hit the metal target, X-rays are produced.
Yeah.
Okay.
That electron will go and hit with the another electron inside, and that electron will be promoted to an excited state. Due to the difference in energy level, here that diagram, a photon will get emitted. So that means normally here also the same thing, photoelectric effect also, all the photons go and hit the metal surface. But I told like with 1000 photons hit, like 250 electrons or 200 electrons coming. Now all the electrons which are going hit will not produce X-rays. Now let's say 100 electrons are going and hitting there, only like 10 or 20 X-ray will be produced. That means everything can't produce. It should hit at the correct place, and lot of factors it is affecting. Okay. This is like
Okay.
X-ray, you can think it is other way around to the photoelectric effect. Now what we studied in the photoelectric effect, it is opposite to that. Okay. Then the target. Now you see what happens is now these electrons are going and hitting the metal surface with very high speed, right? And here this voltage is like 10 to the power 4 voltage, 10 to the power 5 voltage now. So when it hit with high speed, it will like the target will get heated. So this shouldn't be melted. Therefore, we are using some metals. So write down that the target is a high melting point metal such as tungsten or molybdenum. Sometimes they can ask the metal target what type of metals they are using to make it. The target is a high melting point metal such as tungsten or molybdenum. So normally we use tungsten or molybdenum to make the anode target.
We use it to prevent.
The target is a high melting point metal such as tungsten or molybdenum, in order to prevent to melting. Sometimes if due to the high energy, if we use some other metals, sometimes this target will get melted. In order to avoid that, what we are using is high melting point metals such as tungsten or molybdenum. Okay?
Okay, miss.
Okay. Next is uses of X-rays. So where we use X-rays that you know in medicine, in security purposes, that you know, right?
Yes, miss.
X-rays. Okay. So that is the main, and sometimes they can ask X-ray questions also. They can give the voltage and that equation we studied, and they can ask to calculate also. So another thing is X-rays, like it is short wavelength, highest frequency. In the electromagnetic spectrum, you should know after gamma rays, we have X-rays. Okay.
Yes.
Then,
Miss, today is it 1 hour class?
yeah, 1 hour. Shall we continue tomorrow morning? What time?
I have a class at 6 to 7:30. Shall we do at 7:30 to 8:30?
Yeah, 7:30 to 8:30. So tomorrow, let's start that radioactivity. Next part.
Okay, miss, sure.
Okay. Okay then. Bye. Good night.
Bye, miss. Good night.